Dear students, in this video on kinematics and in motion in two dimensions, we will study uniform circular motion with numerical problems. So let us begin with uniform circular motion and its definition first. So, when a body moves with constant speed on a circular path, it is said to have uniform circular motion. So, if on a circular path you have any body, say this one, and it is moving with constant speed, the speed is constant, then it is in uniform circular motion. Now, if we talk about its velocity, then you see that velocity is always tangential to the path. जो velocity की direction है वो path के हमेशा tangent के along होती है. So यहाँ पर velocity की direction इधर है, यहाँ पर velocity की direction इधर है. तो आप देखिए कि velocity की direction continuously change हो रही है. Velocity का magnitude same है. Magnitude of velocity is speed. So magnitude नहीं change हो रहा है, पर direction continuously change हो रही है. So velocity is changing. And you know that acceleration is change in velocity per unit time. So velocity is changing means there is acceleration in motion, right? So we can say that uniform circular motion is an accelerated motion. Uniform circular motion is an accelerated motion, right? So let's see. See, if we have this body, say A, and say it is in circular motion like this one, and its initial position is R1. Let us take this center as origin, then position vector of initial position is vector R1 and position vector of the final position is R2. See, यहाँ से आपकी बॉडी स्टार्ट हुई और ये टेकिंग दिस पाथ वो यहाँ पे पहुँच गई है, ठीक है. एंड द angle subtended at the center is delta theta, right? And it has moved along this path. So this omega is called angular velocity. The motion is anti-clockwise like this. And you know that velocity is always along the tangent to the path. So velocity is along this path, and then velocity at point B is V2, right? And now let us see. Look at it. Now from point A to point B, velocity has turned through angle delta theta. जिस एंगल से ये जो पोजीशन वेक्टर चेंज होगा, टर्न होगा, उसी एंगल से वेलोसिटी भी टर्न हो गई है. You see? Let's see. If you look at it, this is radius and this is tangent. An angle between radius and tangent is 90 degree. यहाँ भी ये radius है और ये tangent है, इनके बीच का एंगल 90 डिग्री है. तो जिस एंगल से रेडियस टर्न होगा उसी एंगल से इनका टेंजेंट भी टर्न होगा. सो ये एंगल थी डेल्टा थीटा और ये एंगल डेल्टा थीटा, दे बोथ विल बी इक्वल. एंड नाउ दिस डेल्टा आर इज लीनियर डिस्प्लेसमेंट. इनिशियल पोजीशन ए, फाइनल पोजीशन बी, और डिस्प्लेसमेंट इज फ्रॉम इनिशियल पोजीशन टू फाइनल पोजीशन, द डायरेक्ट डिस्टेंस. एंड this arc is the linear distance covered, delta s, length of the path taken. Okay, and now we are going to define certain terms here. First one is angular displacement. Now ये आपको linear displacement दिख रहा है delta r, but ये जो angle है at the center, this angle is called angular displacement, right? So now angle subtended at the center of circular path by the arc length traveled by the body is called angular displacement, right? So, and another interesting thing is that here, no, okay, this angular displacement is a vector quantity and it is a different type of vector. This is called axial vector. Now, see this, if you see the circular path is along this direction, right? Then axis of rotation is normal to the plane containing this circular path. If the अगर ये circular path इस पेपर के प्लेन में है तो इसका एक्सिस ऑफ रोटेशन जो है इस पेपर के प्लेन के परपेंडिकुलर है, ठीक है? और ये जो एंगुलर डिस्प्लेसमेंट डेल्टा थीटा, दिस इज अ वेक्टर और इसकी डायरेक्शन उसी एक्सिस के अलोंग होगी जिस एक्सिस के अलोंग ये सर्कुलर मोशन हो रहा है. सो दिस इज कॉल्ड एन एक्सियल वेक्टर. इट इज अ वेक्टर क्वांटिटी, राइट? ओके, नाउ so angular displacement is an axial vector. It is along the direction of axis of rotation. Its SI unit is radian, of course, and it is a dimensionless quantity because it is angle. And now we will talk about relation between linear displacement and angular displacement also. Now, if the angles are if the angle is small and points A and B are very close, you know this relation, angle is arc upon radius. So angle delta theta is, arc is delta S upon R, or delta S is equal to R delta theta. R is what? Radius of the path, right? So delta S is equal to R delta theta. So linear displacement is product of radius and angular displacement. Now, next definition is angular velocity. The way we have linear velocity, we have angular velocity also, and it is angular displacement per unit time is called angular velocity. Now, this is also an axial vector and it acts along the direction of axis of rotation, and since it is angle displacement per angular displacement per unit time, so its SI unit is radian per second, and its dimension will be t raised to the power minus 1. So you see that angular velocity is angular displacement upon time. See, the unit of angle is radian and unit of time is second. So its unit is radian per second and dimension will be, of course, t minus 1. The formula is omega is theta upon t, or we can also write omega as d theta upon dt, or delta theta upon delta t. Now, angular acceleration. The way we have linear acceleration, we have angular acceleration also. So it is the rate of change of angular velocity with time. Formula: angular acceleration is change in angular velocity upon time taken, or we can also write d omega by dt, right? Now this is also an axial vector. It acts along the axis of rotation and its unit is, this is radian per second upon second. So radian per second square. Dimension will be t minus 2. You know what? Radian is dimensionless. So t minus 2. So some definitions, some more. Time period. So time period is what? It is the time taken to complete one rotation. That is time period. Start from one place and take one complete rotation. Time taken is time period. And 1 सेकेंड में आप जितने इसके रोटेशंस लगा लें, दैट बिकम्स इट्स फ्रीक्वेंसी. सो फ्रीक्वेंसी इज number of revolutions per second, and its SI unit of frequency is hertz. Symbol is Hz. Relation between time period and frequency is nu is equal to 1 upon t. The symbol used for frequency is nu, read as nu. It's a Greek letter. And now relation between linear and angular velocities. So for that we have just done this relation, that linear displacement is equal to radius into angular displacement. Divide both sides by time interval. So delta s upon delta t is equal to r delta theta upon delta t, and this becomes linear displacement per unit time, that is linear velocity. This is angular displacement per unit time. So this is angular velocity. So v is equal to r omega. Very important relation. Relation between linear and angular accelerations. So now see, angular acceleration is rate of change of angular velocity, and v is equal to r omega. So differentiate both the sides. You know that linear acceleration is equal to dv by dt, rate of change of linear velocity. So इस वाली इक्वेशन की दोनों साइड्स को आप डिफ्रेंशिएट कीजिए. The value of v is equal to r omega, and r is constant. So take constant outside. Inside will be d omega by dt. And you know that d omega by dt is angular acceleration alpha. So linear acceleration A is equal to r alpha. Let's see. Linear acceleration is equal to r alpha. So it's very easy to remember these relations. See, linear displacement is equal to r theta, linear velocity is equal to r omega, and linear acceleration is equal to r alpha. So angular acceleration, angular motion की सारी टर्म्स को r से मल्टीप्लाई कर दीजिए और लीनियर मोशन वाली टर्म्स आपको मिल जाएंगी. And now very important relation between omega, nu and t, angular velocity, frequency and time period. And let's see how we do it. Okay, now let us consider its motion for one time period. So if you consider the motion for full one time period, the angle subtended at the center will be equal to 2 pi, right? And then see, the total time taken is t and the angle subtended is 2 pi. So the angular velocity becomes, see, for one complete time period, you know that angular velocity is angular displacement upon time taken. One complete time period के लिए angular displacement है 2 pi 360 degree, and total time is time period. And from here, see, 1 upon t is frequency nu, so 2 pi nu also. So combining them together, we get angular velocity is equal to 2 pi upon t is equal to 2 pi nu. Very, very important relation. You must remember it. And now we are going to find out relation for acceleration in uniform circular motion. So here the same diagram, no change, absolutely same diagram. And let us see how we find out acceleration. See, we have to find out, see, for acceleration, you know that acceleration is change in velocity upon time taken, right? So for that I have to find out change in velocity. और आपको पता है कि एक velocity ये है और दूसरी velocity ये है, v1 and v2. So I have to find out final velocity v2 minus initial velocity v1. So that is going to be the line of action. and vector subtraction करेंगे हम. Now both the vectors r1 and r2, they have same magnitude which is equal to radius, and both the velocities, this one and this one, have same magnitude which is equal to v and which is equal to speed. And now see, since I have to take vector subtraction, so इसके पैरेलल एक वेक्टर बना दिया और इसके पैरेलल भी एक वेक्टर बना दिया. ठीक है, velocity v1 and v2, and the angle between these velocities is also delta theta. Just see, the angle between the two position vectors r1 and r1 is r1 and r2 is delta theta, और इसकी परपेंडिकुलर ये वेलोसिटी और इसकी परपेंडिकुलर ये वेलोसिटी, तो वेलोसिटीज के बीच का एंगल भी डेल्टा थीटा ही होगा. So this angle is also delta theta, right? And one more thing, you see that this vector v1 plus this vector v2 is equal this vector tail to head v1 plus second vector tail to head, and this third one is first tail to last head. That means v2 is equal to sum of this vector and this vector. That means if these two are known to us, then this should be difference of this one and this one. So this vector is v2 minus v1. So you can see that this third vector is change in velocity. Final velocity v2 minus initial velocity v1, right? And look at it. This velocity is directed towards the center of the path. And one more thing, see, in this triangle and in this triangle, these two sides are equal, isosceles triangles हैं, और ये जो vertex का angle है, vertex angle भी दोनों का same है. That means these triangles are similar triangles, and similar triangles हैं तो corresponding arms का ratio भी same होगा. So that means this upon this will be equal to this side upon this side. So that is what we are going to do. Ultimately I have to find out delta v, change in velocity. So you know that acceleration is magnitude of change in velocity. This is delta v. So v2 minus v1 is का magnitude upon time taken. So in similar triangles, as I have just discussed, delta v upon v, this delta v upon v is equal to delta r upon r, and acceleration a is delta v upon delta t. So from here, from this place only, you take this v to the right hand side and divide by delta t on both the sides. So this v goes to the right hand side, I get this v, r यहाँ पर already है, और डेल्टा टी से मैंने दोनों साइड डिवाइड कर दिया. डेल्टा टी से यहाँ भी डिवाइड किया और यहाँ भी डिवाइड कर दिया. सो डेल्टा वी अपॉन डेल्टा टी आ गया और डेल्टा आर अपॉन डेल्टा टी आ गया. And this delta v upon delta t is acceleration a. So in one step only I have done all these things, and this delta r upon delta t is displacement upon time taken, which is equal to velocity. So this v upon r ये आपके पास already है, into एक velocity और आ गई, and multiply it, you get v square upon r. So finally we get acceleration a is equal to v square upon r. This is magnitude of acceleration, and we get this important relation now. So this acceleration a is v square upon r, and you know that v is equal to r omega. So when you put the value, you can get r omega square also, right? So very, very important relation. This is acceleration in uniform circular motion. Now since it is a vector quantity, we have to find out its direction also. And direction of acceleration will be same as direction of v2 minus v1. Direction of acceleration will be same as direction of v2 minus v1. So we are going to study this one once again. See, if these two points are very close, अगर point A और B बहुत close हो जाए, तो ये velocity, ये वाली velocity और ये velocity, these velocity will become nearly parallel. See, the velocities will become nearly parallel. And when okay, let me draw them like this. And if the velocities become nearly parallel, this angle will become negligible, and this delta V will make an angle 90 degree with this one. And you know that angle between this tangent and this radius is 90 degree. That means this delta V should be directed towards the center. Radius center की तरफ होता है, तो delta V भी center की तरफ होगा. And look at this arrow. Arrow की direction center की तरफ जा रही है. तो that means acceleration भी center की तरफ ही होना चाहिए. So acceleration should be directed towards the center. So let's see how we write it. Direction of this vector acceleration. So when points A and B are extremely close, v1 and v2 are nearly parallel. So this vector delta V is directed towards the center. And as vector A is along delta V, it is also directed towards the center, and hence this acceleration is called centripetal acceleration. ये जो वेक्टर है आपका वेक्टर एक्सेलरेशन का वेक्टर है, इस एक्सेलरेशन को कहते हैं सेंट्रीपिटल एक्सेलरेशन. So acceleration in circular motion is towards the center. So it's a very important outcome from here. So that means if I have this circular motion, then the velocity is along this direction, tangential, but acceleration is towards the center. And it is called centripetal acceleration. Very important derivation. And now let us take a numerical problem where we are going to use all these formulae. So let's see. 100 gram stone is tied to a 70 centimeter long string, and it is whirled in a horizontal circle at constant rate of 60 revolutions in half a minute. Find frequency, time period, angular velocity, linear velocity and centripetal acceleration. So what is given to you is कि एक 100 ग्राम का स्टोन है और इसको आपने एक 70 सेंटीमीटर लॉन्ग स्ट्रिंग में इसको बांध दिया है, टाई किया है, और इसको हॉरिजॉन्टल सर्किल में घुमा रहे हैं. एट व्हाट रेट? 60 revolutions in half a minute. So you have to find out all these things. See here and here, one by one. Let us take frequency. Now frequency is given 60 revolutions in half a minute. Half a minute is 30 seconds. So you get, simplify it, you get 2 hertz. Frequency is 2 hertz. Time period is reciprocal of frequency 1/2, that is 0.5 second. Angular velocity is 2 pi nu. So nu is 2 hertz, multiply कर दीजिए, you get 4 pi radian per second. Remember, units are important. You have to write units. Now, linear velocity, v is equal to r omega. R is given to be 70 centimeter. So 0.7 meter. Convert to SI unit and put the value of omega from here, which is pi, 4 pi, and pi is 22 upon 7. So you simplify it and the velocity comes out to be 8.8 meter per second. And now centripetal acceleration A is v square upon r. Now v is this much. So multiply कीजिए, r is 0.7 meter, divide, and acceleration comes out to be this much, and unit is meter per second square. It is acceleration only. So in this way we can use all these formulae of uniform circular motion. Thank you for watching this video, and I hope that it is useful to all of you.